Hello, everyone. Welcome back to another episode of Programming in Rust. We are continuing from the previous episode, talking more about structs. Just a brief recap. What is a struct? It's equivalent to a class in any object-oriented programming language. This is an example. So let's say, for example, user, you define the field and its data type. So whether the user is active, username, its type, sign-in count. So this is basically a strut, which lets you organize fields or properties related to a particular object into one particular object. You can create an instance of a struct using the strut name or the object name, followed by the parentheses and assigning values to the different variables. You can also you can also change the value of the variable after assigning it. This is how you do it, or rather, how do you access the field after creating the object, after creating the instance? It's the instance name dot the field name or the property name. But if you have to change it, thing to notice is that it needs to be mutable. The declaration has to be mutable. Otherwise, Rust will throw an error. By default, every object is immutable. Here, this is just another example. This is again a brief recap from the previous episode. You can create another instance and you can use the properties of previously defined variable into the new variable, into the new instance, and just change one field. If you want to know more about it, you can go and watch the previous lecture. Okay, today's lecture is focused on adding behavior or methods to structs. So methods are similar to functions. The keyword to define it is fn, which indicates a function, the name of the function or the method. Methods can have one or more parameters or zero parameters, but any method will always have a self as the first parameter, wherein you are passing the instance of itself to it. Now, this is similar to, I think, programming languages in Python, where when you call the init method, the self is automatically passed. The self is automatically passed by the Rust compiler when you call the method. To define the function, now here, see here, you have another important key point is the definition of strut is this. Like, see the open and close parenthesis. And then immediately following it, you have the impl keyword, which implements the strut which you have defined. So this is the keyword that you need to use. Then the keyword fn, which indicates a function, any method name, and the parameter. This is its return type. It returns an integer. Nothing, it's just an area function which multiplies the width by height and returns it. How do you invoke the method? See here. You create the instance of the strut that we discussed in the previous lecture or just a little while ago, and then you call the method again by dot notation. This is very common to any other programming language. So the instance name dot the method name. Now, if you notice here, we are not passing self. This is passed. If you notice the definition of area, it's ampersand self. But here, see, how do you invoke? Which means Rust internally will pass this instance on which it is invoked, on which the function is invoked. It will pass it to it. And the variables that you have used or the values that you have used to assign it to different properties, it will use it here. And see, how are you accessing it? This self dot. Okay. So it is within the context of rect1, the variable rect1. So when you invoke the method, the instance of rect1 will be passed to the method. Methods must have a parameter named self or of type self. So, I mean, Rust lets you abbreviate it in the form of ampersand self, okay? So now here, another thing, everything within the impl block, you can have multiple functions also, not necessarily one function. You can have multiple functions also. Everything within the impl block is associated with a rectangle, or rather the struct, which you are implementing it. Okay, so this syntax is a little bit different from the other programming languages, wherein the entire class is encapsulated within one class object. So let's say if you're familiar with Java programming language, you define a class, you define variables, and everything, all the methods related to that class are encapsulated within the class declaration itself. Now here, see, when I say class declaration, I mean is the open parentheses and the closed parentheses of the class definition. Here it's a little bit different, where you first define just a struct with its properties, and then impl is outside it. See, it's not within the curly braces. Within this one impl, you can have multiple methods, but this impl itself is outside of the struct. So here, see another example. This function can have one impl, one implementation of a struct, can have more than one method defined. See here, you have an area and another sum function called as can hold. Each of them has the first parameter as self, as we saw earlier, and it could be any other parameter. Okay, not necessarily the other instance, it could be any other parameter. And this is just the return type. But in order for it to be called as a function, the self, which is the instance on which the method is invoked, need to be passed. But what if you don't need the property values? Then you have the associated functions. Again, associated means the function is associated with the struct. So the square is associated with rectangle. The key difference being that it does not need an instance of self. The keyword is still the same, function, fn, just same what you use to define a method. The very key difference is there is no instance. Now, since there is no instance, the thing to note is you cannot access any properties there because there is no instance associated with it. Therefore, associated functions are generally used as constructors, because constructor is something where you create the instance. Where you don't have the instance yet, you create it. So see, for example, here it returns a self. So for this function, you pass the parameter, the size, because it's a square, width and height are same. So whatever value you pass, it will construct an instance of self and return it. So see, you're constructing a rectangle with width and height the same as what you passed. Okay. Now, since there is no instance associated with it, you can also invoke it using this way. We have used the syntax previously when we were creating strings and all in the previous lecture, the double colon, it's called on a non-instance method. See, for example, square 3. Okay. The self keywords in the return body of the function are aliases for the type that appears after self. So this self is for this. How will it know, since you're not passing an instance, how will it know what to create? Because see, you're not giving the name rectangle, like how in the previous few examples, when we created an instance of user, you gave, see here, so we gave user, right? So that's how it knew that you need to create an instance of user. But here, if you see, you're not giving the instance name. So how does it know which strut object to create and return? It depends upon the impulse. So it's associated with the impulse. So in this scenario, it knows that it's associated with rectangle strut. It will create an instance of it and return it. So you can either use it this way, or you can actually create an instance and call dot square. So here, see here, you create a square, you create an area width, or rather, how do you call it? How do you call it? R dot area or R colon. You can call it either way. In either way, this is just an assertion that they are equal. So internally, strut converts this way of invocation, the dot invocation, into this. Okay. Another important thing to note, that needs to be mutable. When you declare the variable of the tribe, it needs to be mutable. Let's see something in action. Let's see something in action here. So I need to show you this here. We have defined a strut, area, set width, function max. We're not worried about it. So I create an instance of rectangle. I set the width to 1 and I print an area. So what I'm expecting is that it should print 5. See, I am initially creating the rectangle wherein I'm passing the width to 0. I'm updating the width to 1. And then I'm printing the area. Now I can do this statement only because I've defined it as mutable and I have not passed rectangle as a method parameter to some other function, okay, which passes the ownership. Let's see this in action. Here. So you use cargo run and it creates, and you can see here, printed 5. Now here, see, something that ownership in Rust, what I'm trying to do here is, I'm trying to assign whatever value the Rust is pointing to, see the pointer, the memory location, into this guy, a new variable, and I'm trying to update it. Now what happens is, even though I'm passing this is not mutable, and Rust will throw an error. Because set with what it does, it modifies, it needs a write permission. Okay, it needs a write permission to set or change a variable value. See what happens when you run this program now. So what I have done is assigned the memory location, what this guy is pointing to, into another variable, and I am trying to change the width. So let's see what happens. Here, Rust throws an error. But the beauty of it is that actually Rust shows you how to fix it. See here, the error is a reference. So the data it refers to cannot be borrowed as mutable. It's a reference. How do you fix it? So consider changing this to be a mutable reference. So you see here, this is how you fix it. So let's try to fix that and see if it works. So I'm making it as a mutable reference. Now let's run and see. So now I set the width to 2, and what I do is I will try to print the area now on rect ref. Okay, rect ref on this one. So hopefully prints 10. Let's see. There you go. That's it. Right? So this was all for today. Talking a little bit, giving you more information about different methods that you can add to structs. difference between methods and associated functions. Associated functions are generally used to construct the instant object. All methods on a struct needs to have the first parameter as a pointer to itself or a reference to itself. But you don't need to create an instance and pass it. It depends on the instance name on which you're calling the method, on which you're invoking the method, and Rust will automatically pass the instance. That was all for today. Hopefully practice some examples and all which is there, okay, into Rust. And hopefully see you all again in the next lecture. Thank you.